Alright, so there's about 20 problems left to do, 10 evens and 10 odds. I'm just going to jump into them. The rest of the problems we're going to have to do mostly by hand. We're going to do a little bit on our calculator just to speed up the process, because each of these problems is asking me to find an area between two curves. I have to know which graph is on top and which graph is on the bottom. So I'm going to, when I do problem 12, I'm going to graph each function. I'm going to make the top function the y1, the bottom function the y2, and what we're asked to find in problem 12 is the area of the region between x equal to 1 and x equal to 5, bounded between these two functions. And so ultimately, I know I'm going to integrate between 1 and 5, and I'm going to take the top function and subtract the bottom function. What I have to find out is if in the window between x equal 1 and x equal to 5, if the graphs cross, or if one function is on top the other time, the whole time. So let me graph each function, and when I do this problem 12, I'm going to go y equals clear. The first thing I'm going to do is 1/2 x, so 1 divided by 2, x minus 1. And let me change my window to 1 to 5 so I'm not looking at anything else that I don't need to worry about. And that's just going to give me a line. And boy, that doesn't look so great. So it doesn't look so great because I can barely see the graph. Let me change my y's a little bit. Maybe that's going to help me. Maybe it's not going to help me. But I'm going to change my y's from -5 to 5 and see if I can see better what's going on. So there's the graph of 1/2 x minus 1. And now I'm going to go in for y2, and I'm going to graph x squared plus 2x minus 1. Well, now the window isn't so good for this function, but it looks like the x squared function is always on top. Let me blow my window up a little bit bigger so I can see the other graph by changing my x max. So there's my line, the f function. There's my parabola, and it goes up even higher. I don't know how high to make this. The important thing is, over this window, the line and the parabola don't cross. And over this window, the parabola is on top the whole time. So when I look at the graphs, the one function looks like this, the parabola, and the other function looks like this, the line. And the important thing is that between x equal to 1 and x equal to 5, the parabola is always on top. So I'm stealing from my calculator which function is on top. If the functions cross, I'm going to have to go by hand and figure out where they cross. So my problem number 12, I'm going to go and I'm going to integrate the top function, which is x squared plus 2x minus 1, minus the bottom function in a parentheses, which is 1/2 x minus 1 dx. And it would be nice if I bracketed all this. And I have to integrate between 1 and 5 because I was told I'm finding the area between 1 and 5. Because I'm doing this by hand, it's probably going to be really worth my time to simplify this a little bit. So let me make this the integral from 1 to 5 of x squared plus 2x minus 1, and then clear the parentheses. I'll get a minus 1/2 x and a plus 1 dx. And the minus 1 and the plus 1 cancels, which is really nice. What I have to worry about combining is 2x minus 1/2 x. And for 2x, I'm going to make it 4x over 2. I already wrote it over 1 because 2x is equal to 2x over 1. So to combine this and this, the 2x needs to have a denominator of 2. So I'm going to make it 4 halves x minus 1 half x, because 4 halves is 2, so 2x is equal to 4 halves x, and that's going to give me a 3 halves x. So I'm going to get the integral of from 1 to 5 of this x squared term is going to stay here. These two are going to combine to be plus 3 halves x dx. Alright, now I'm going to do the integrating. I'm going to do it off to the side because I'm getting close to the bottom of my work here. So for this, I'm going to add 1 to the exponent, get an x cubed, divide by the new exponent over 3, plus, for this one, it had an exponent of 1. I'm going to add 1 to the exponent and get an x squared. And either I can divide by 2 or multiply by 1/2, because you can always multiply by the reciprocal of what you're dividing by. And for those, I'm going to multiply by the reciprocal. And I need to evaluate this from 1 to 5. So this is going to be, what? X cubed over 3 plus 3/4 x squared evaluated from 1 to 5, which means I have to first find 5 cubed over 3 plus 3/4 times 5 squared, get a number for that, and then subtract what you get when you do 1 cubed over 3 plus 3/4 times 1 squared. I'm going to use my calculator to get both of these, and they're probably going to turn into decimals. I'm going to make those decimals into fractions. So let me give this a go here. So first computation, this new doc cam that I have this summer, I've just really grown to dislike. It's so hard to get, for me at least, to get the screen straight, which is not so great for you, and it's really hard to work with for whatever reason. So there's my 5 cubed over 3 plus 3/4 times 5 squared, and math, enter, enter. That gives me 725 over 12 for the first half of this. And then the second half, I'm going to do clear 1 up arrow 3 divided by 3 plus 3 divided by 4 times 1 squared. Math, enter, enter. That's 13 over 12. So now I'm going to go 725 over 12 minus 13 over 12. And I get 178 over 3. That's going to be my answer. Parenthetically, I'm going to write 59.333. And now I'm going to check my answer. I'm going to check my answer by integrating this on my calculator. So on my calculator, I'm going to enter into y1 x squared plus 3 halves x, and graph it. Don't really care about the windows too much. And integrate it from 1 to 5. So second calc, x equal to 1, x equal to 5. I better see that 59 number. Awesome. So I did it spot on, perfect. Using my calculator when I can, but a lot of this needs to be shown by hand. So give number 11 a go, and we'll 10 more problems, but that took 10 minutes, so it's going to take some time. Alright, so for problem 14, I'm given the functions f of x equal to x cubed and f of x, or g of x equals 4 square root of x. I need to graph and figure out which one's on top. So I'm going to go, first I'm going to graph x up arrow 3, and my window needs to go from x equal to 0 to x equal to 1. And I don't know what my y should be. I'm going to put them back to a negative 10 to 10. So there's the x cubed function over this window. Again, the window is not good at all for this x cubed function. So let me crunch my y's down a little bit, maybe negative 2 to 2. And so now I can see better the x cubed function. it actually gets so close here to the x-axis. It's always above the x-axis. It gets so close to the x-axis you can't even see it. So between 0 and 1, what the x cubed function does is it does that. Now let me try the 4 square root of x. I don't know if under this window, well, it's going to be fine, I guess. Let me bump my window up a little bit so I can see that 4 square root of x a little bit higher. Let me make this like the 6. Start losing perspective of the x cubed function when you gain perspective of the, it looks like that, I guess. So clearly, or semi-clearly, I think at the whole interval, the square root function is on top, so my g is the top function, and my f is a bottom function. So what I'm going to have to integrate to get this area is from 0 to 1, because I was told 0 to 1. The top function is the g of x the whole time, and I'm going to write it as 4x to the 1/2 rather than writing the square root and making the square root into a fraction exponent. So because this function's on top for the entire interval, I only need one integration, top minus bottom. And I'm going to integrate. Here I'm going to add 1 to the exponent, and I'm going to add 1 in the form of 2 over 2. My new exponent's going to be 3 over 2, and I'm going to multiply by 2/3 for that. Bring down my minus sign, add 1 to the exponent, divide by the new exponent, and I know I need to evaluate from 0 to 1. This right here, I'm going to multiply the 2 and the 4, and I'm going to get 8/3 x to the 3/2, which is the square root of x cubed, minus x to the 4th over 4, evaluated from 0 to 1. So now I need to evaluate it at 1, evaluate it at 0, and subtract. So evaluating it at 1, I'm going to go 8/3 times the square root of 1 cubed. Because the 1 is positive, it really doesn't need to be in a parentheses. Minus 1 to the 4th over 4. Again, because the 1 is positive, it doesn't really need to go in a parentheses. As long as it's not negative, when you're doing an exponent, you don't need a parentheses. Second parentheses, I'm going to go 8/3 times the square root of 0 cubed minus 0 to the 4th over 4. I'm going to get two values. I think that one's going to be 0. And the two values I'm going to get using my calculator on the main screen. So second quit. First parentheses is 8 divided by 3 times second square root of 1 up arrow 3 minus 1 up arrow 4 divided by 4. And I get 2.41. Math. Enter, enter. I get 29 over 12. Second one, I think it's a 0. For the second one, I'm going to go parentheses 8 divided by 3, and then second square root of 0 up arrow cubed minus 0 up arrow 4th divided by 4, and I do get 0. So the whole answer to this, to problem 14, is 29 over 12, and that 29 over 12 is equal to 2.41667, or 2.41, like that. I'm going to do this on my calculator, meaning I'm going to integrate that on my calculator to make sure I get this number, so I haven't made a mistake here that I can find. So what I can do on my calculator is I can check. So now I'm going to go 4. I can do x to the 1/2, or I could do square root of x. My calculator, it's just as easy to enter the square root of x. When I'm integrating by hand, the square root symbol doesn't help me. So that's that function. Graph it. Now I'm going to integrate from 0 to 1, and hopefully I get that number. So second calc, 7, lower limit 0, upper limit 1, 2.41. Close enough. So it's bang on perfect. So give 13 a go. Same idea. It's just figuring out what function is on top, what function is on bottom, in the given interval. If they cross, you're going to have to separate it, your answer, into two separate integrals, but for now, I don't think they cross just yet. So moving on to 16, I need to graph x squared minus 9x in my y1 minus x squared in my y2 minus 8x squared and see which is on top in the window from 0 to 1. I already have that window from 0 to 1 in. Let me change my y's back to negative 10 to 10 because that's usually where I like to start. So clear out this function. First function I integrate is x squared minus 9x over 0 to 1. Nice, easy function. It's beneath the x-axis the whole time. Now let me do negative 8x squared in my y2. So negative 8x squared, graph it. They cross, or they meet, but it looks like they meet at 0 and looks like they meet at 1. I'm going to gamble that's the case without really confirming that. But I know that if I plug 0 into this, 0 squared minus 0 is 0. If I plug 0 into this, negative 8 times 0 squared is 0. So they both meet at the origin. And if I plug 1 into this, if I plug 1 into this and 1 into the other one, if I do 1 squared minus 9 times 1, you get 1 minus 9, which is negative 8. If I plug 1 into this, you also get negative 8. So the fact that when I plug 1 into both functions, I get negative 8 tells me they meet at 1. And if I plug 0 into both functions, I get 0, they meet at 0. So at 0 and 1, they actually meet. But the whole time, the negative 8x squared function is the top function. So that I'm going to integrate from 0 to 1, the top function, negative 8x squared, minus the bottom function, which needs to go in a parentheses because it's a binomial, and now I'm going to simplify and clean up the parentheses here. So I'm going to get negative 8x squared minus x squared plus 9x dx. This is a negative 8 minus a negative 1x squared. So it's really going to be a negative 9x squared. So it's negative 9x squared plus 9x dx. Evaluate it from 0 to 1. Now I'm going to integrate. Here I'm going to add 1 to the exponent and get an x cubed. Divide by the new exponent, which is 3. Second piece, add 1 to the exponent and get an x squared. Divide by the new exponent. Evaluate it from 0 to 1. Of course, I can simplify this to be minus 3x cubed plus 9x squared over 2. Evaluate it from 0 to 1. So now I'm going to do my evaluations. I'm going to do negative 3 times 1 squared plus 9 times 1 squared over 2, and then minus negative 3 times 0 squared plus 9 times 0 squared over 2. This one's going to be 0 again. This is going to wind up probably being the driving part of my answer. So now on my calculator, first parentheses, main screen, negative 3 parentheses 1 squared plus 9 times 1. Oh, this should be cubed. This should be cubed, cubed, cubed. I dropped my exponent there for no real reason. Fix it before I mess up. So it might not matter because 1 is a forgiving number when it comes to exponents. So that looks close enough to what that is. In math, enter it. And this one comes out to 3/2, which is 1.5. And then the next one's going to come out to 0. And my answer is going to be 1.5. But let me do that next one to make sure. So for the next one, I'm going to go minus 3 times 0 cubed plus 9 times 0 squared divided by 2, and I get a 0. So I get 3/2 minus 0, and my whole answer to problem 16 as either 1.5 or 3/2, but I want the fraction answer. So the area that's found by the description of the problem is that. Let me make sure. I'm going to enter this on my calculator to make sure that comes out to 1.5. So go into my y equals, clear the stuff that's in there, do negative 8x squared minus parentheses x squared minus 9x, graph it, and then integrate between 0 and 1 and hope I get 1.5. Now second calc, 7, 0, enter 1, enter 1.5, so I did it perfectly. The truth is, if I didn't catch that mistake, because 1 to the second power is the same as 1 to the third power, and 0 to the second power is the same as 0 to the third power, I still would have gotten the correct answer. All right, so give 15 a go. These problems take a monstrous amount of time. My gut feel is, because the functions in 17 and 18 are so easy, that they're probably going to cross. So let me, in my window from 1 to 6, graph the f function and the g function. If they cross, I need to find the x-coordinate of where they cross. If that x-coordinate's an integer, I'll steal my calculator to get the x-coordinate. So I'm recalibrating my x's to only handle the x's that I need to look at. And I've entered the first function just so I can differentiate it from the second function. And now I'm going to graph the second function, negative x plus 7, add into y2. And I'm going to watch closely where it's on top and where it's on the bottom. So at first, the negative x plus 7 is on top until there. Then it becomes on the bottom. I need to find the x-coordinate of where they meet. And if my calculator gives me an integer, we'll use my calculator's work. If my calculator gives me a decimal, I need to do it by hand. So to find the x-coordinate of this point, I'm going to go second calc, intersect, trace as close as I can to where those two graphs intersect, and hit enter 3 times. It's being lazy, but it works. As long as it's not a decimal, I don't have to do algebra. If it's a decimal, I have to do algebra. Oh, beautiful. So what I have in terms of this, between 1 and 6, and then at 5, the negative x plus 7, which I'll do in orange, is on top for most of the interval, but not all of the interval, because the x minus 3 comes on top at x equal to 5. This is x equal to 5 where they meet. So I have to do 2 integrals. One's going to be from 1 to 5. The other is going to be from 5 to 6. The first integral, the top function is the g, and the bottom is the f, and then they switch. So I'm going to have to do 2 integrals. The first integral is going to be from 1 to 5, where the top function is the negative x plus 7. The bottom function is the x minus 3. And then I'm going to integrate from 5 to 6. The top function now is the x minus 3, and the bottom function is the negative x plus 7. So let me do both of these. So I need to clear out these parentheses in here. So this is going to be the integral from 1 to 5 of negative x plus 7 minus x plus 3 dx. The second integral is going to be the integral from 5 to 6 of x minus 3 plus x minus 7 dx. This one, the x's both have negative 1s that are implied in front of them, so it's going to give me a negative 2x. And then 3 and 7 is plus 10. And the next one, x plus x is 2x, minus 3 minus 7 is minus 10. All right, so now I'm going to integrate these. I'm going to add 1 to the exponent, get negative 2x squared, divide by the new exponent, and then for the 10, its integral is 10x. These I have to evaluate from 1 to 5. This next one, when I integrate it, it's going to be 2x squared over 2 minus 10x, evaluated from 5 to 6. When I simplify this, you get a negative x squared. On my calculator, it's going to be well worth my time to leave that negative 1 in front of the x squared. It's going to keep me from messing up as much. So this is what I need to accomplish. I need to plug in 5 and 1 into this function, 6 and 5 into this function, and do a little extra work. So for the left version of this, I'm going to go parentheses with a minus. And for this version, I'm going to do a parentheses with a minus. And this is a plus sign between. So here I'm going to go negative 1 times 5 squared plus 10 times 5. And then negative 1 times 1 squared plus 10 times 1. Didn't leave myself enough room for that at all. Let me do this let me just write here what I'm going to do. For this one, I'm going to go 6 squared minus 10 times 6, and then 5 squared minus 10 times 5. And I didn't have enough room to put a parenthesis, so I put a times sign there. So all 4 parentheses that I need to get done right now. First parentheses, I can quit, clear, negative 1 times 5 squared plus 10 times 5 is 50. This parentheses comes out to a 25. And then negative 1 times 1 squared plus 10 times 1 is 10. So the first area is 16. For the second area, this is going to be 36 minus 60. So 6 squared minus 60 is a negative 24. And then minus 5 squared, that's minus 5 times 10 is minus 50, which is minus a minus 25. And that's going to be minus 24 plus 25, which is a positive 1. So the combined areas in my answer to this problem is going to be 17. What I want to make sure of on my calculator is that this area comes out to 16, and this area comes out to 1. And I'm going to do it all the way down here. I'm going to do that on my calculator and that on my calculator, hoping I didn't make a mistake somewhere between here and there. So double check this real quickly. Go y equals clear, clear, negative 2x plus 10. Graph it. And then second integrate. Oh gosh, we'll find out what happens here. Second integrate from 1 to 5. Get that 16 that I wanted. Next one, I'm going to integrate from 5 to 6. And it's going to be the function 2x minus 10. And that function I'm going to integrate from 5 to 6. Hopefully I get 1 for an answer. It worked out perfectly. First one came out to 16, second one came out to 1. I add the 2 areas together and get 17. So give problem 17 a go. It should be real similar in that the functions probably cross at some value of x, and so your top and your bottom functions are going to flip on you. My guess is the same thing's going to happen for 20 as well as 22. So for 20, I need to look at my window, my graphs between negative. So I'm going to graph this in y1 over that window, and then this in y2. My guess is they're going to intersect. So I need between x equal to negative 2 and x equal to 5, I need this function and that. This is a line, this is a parabola. They'll be easy to tell apart. So y equals clear 2x plus 9, and then for my window, negative 2 to 5. Graph that a little bit. Shoots way off the window. Let me make my y's higher. so I can see that. Maybe make this y like a 30, just because I want to see the whole function. So this line graphs to be something like that. And again, I'm just worried about which function's on top and which function's on the bottom. I don't need the most precise graph in the world. Now I'm going to do the x squared plus 1 over that same window and graph it. And there they do cross. So it looks to me like this. That looks like so that between -2 and this value of x, the line is on top, and between this value of x and 5, the parabola is on top. I need to get this value of x. If I can go second calc intersect and it comes out to an integer, I'll take my calculator answer. If it comes out to an ugly decimal, I need to do it by hand. So find this intersect, go second calc intersect, trace as close as you can to where they hit intersect, then hit enter 3 times. So enter, enter, enter. Luckily enough, I get a nice value there. That's a value of 4. So first integral is going to be from -2 to 4. Top function is 2x plus 9. Bottom function is x squared plus 1. And then I'm going to integrate from 4 to 5. Top function is now x squared plus 1. Bottom function now is 2x plus 9. I'm going to do these on separate sheets, on a separate sheet of paper, because it's taking so much room already. So I'm going to do this separately from this. I'm going to get two numbers and add them together. So the first computation that I'm worried about is the integral from -2 to 4 of 2x plus 9 minus x squared plus 1 dx. Let me clean that up. I'm going to go -2 to 4 of 2x plus 9 minus x squared minus 1 dx to clear that parentheses. The plus 9 and minus 1 give me an 8. I get the integral from -2 to 4 of -x squared plus 2x plus 8 dx. Now I'm going to integrate, add 1 to the exponent, divide by the new exponent. I'm going to get -x cubed over 3. I'm going to write that 1 in there so I don't get messed up. Next one is going to be 2x squared over 2. I'm just going to write an x squared. I don't need the 1 so much because it's not negative. And then the last integral is positive 8x. That I need to evaluate from -2 to positive 4. So I need to go -1 times 4 cubed over 3 plus 4 squared plus 8 times 4. And then minus, same deal, didn't leave myself enough room, -1 times -2 cubed over 3 plus -2 squared plus 8 times -2. Do both of these on my calculator just because it's easier for me. So left one, second quit, clear, -1 times 4 cubed divided by 3 plus 4 squared plus 8 times 4. Math, enter, enter. I get 80 over 3 for this number. And then minus, and then do the next one. Next one is -1 times -2 cubed divided by 3 plus -2 squared plus 8 times -2. Math, enter, enter. That's -28 over 3. The double negative is going to make a positive here. So this is going to be 80 over 3 plus 28 over 3, which is lovely, 36. So I'm going to double check that on my calculator, that this one comes out to be 36. Let me just enter that function like that, because it's not so hard to enter, and I'm going to double check to make sure I get 36 for that half. So y equals clear, clear, 2x plus 9 minus parentheses x squared plus 1, close out my parentheses, graph it. And then second calc, option 7, negative 2, enter 4, enter. I want to see a 36 real badly, and I did that spot on perfectly. Now I'm going to move on to another sheet of paper and do this one. So I'm trying to find the integral from 4 to 5 of x squared plus 1 minus 2x plus 9 dx. That's going to be the integral from 4 to 5 of x squared plus 1 minus 2x minus 9 dx. 1 minus 9 is negative 8. That's going to be the integral from 4 to 5 of x squared minus 2x minus 8 dx. Now I'm going to integrate. That's going to be an x cubed over 3. This is going to be a minus 2x squared over 2. So it's going to be a minus 1x squared. That's going to be a minus 8x. When there's a minus 1 in front of the x, I usually write it because it makes it so I don't make mistakes in my calculator. Now I need to plug 5 in, and I need to plug 4 in. So I'm going to go 5 cubed over 3 minus 1 times 5 squared minus 8 times 5. And then I'm going to do 4 cubed over 3 minus 1 times 4 squared minus 8 times 4. Both on my calculator. Because the 5 and 4s are positive here, I don't really need a parentheses. To be safe, I used parentheses here because that negative 1 in front, I wasn't sure what was going to happen if I didn't put the parentheses in. So back to my main screen. First one, 5 up arrow 3 divided by 3 minus 1 times 5 squared minus 8 times 5. Math, enter, enter. I get negative 70 over 3 for the first one. Bring down the minus sign, work on the second one. 4 up arrow 3 divided by 3 minus 1 times 4 squared minus 8 times 4. That's minus 80, minus a negative 80 over 3. So I need to go 70 over 3. Did that come out to a positive? I can't go back. I'm afraid. I'm going to do this again. I'm afraid I forgot a sign. We do that 5 up arrow cubed divided by 3 minus 1 times 5 squared minus 8 times 5. It was negative. Forgot the negative sign. So this is negative 7 over, this is negative 70 over 3 plus 80 over 3. That's going to be a positive 10 over 3. That's like 3.33 as a decimal. I'm going to check this real quickly on my calculator to make sure that this area comes out to 10.33. So on my calculator, y equals x squared plus 1 minus parentheses 2x plus 9. Graph it. Second calc, integrate from 4 to 5, and I get exactly that 3.33 that I wanted to. So I know that this area is the 10/3. So the second area that I found is 10/3, and now I just need to add the two areas. I calculated this area, then I calculated that area. I'm going to add them together by going 36 plus 10/3, and that'll be my answer. So finishing this up, I'm going 36 plus 10 divided by 3, math, enter, enter. My shaded area represented there is 118 over 3 square units. So the answer to problem 20 is 118 over 3, and then I don't put the units squared in, but you could put them in just fine. So Just tedious as heck, these problems, but hopefully they're not particularly challenging because the integration isn't that bad. Plugging the numbers in I'm really doing on my calculator. So for the most part, these are fairly clean. So give 19 a go, and now I'm going to move over to 22, and then I'll probably pause and make like a third part to the video because it's getting long and there's an extra part after this. Alright, so for 22, I need to look between 1 and 6 at the functions f of x and g of x. So I'm going to graph them again. I don't know what the windows should be ahead of time. I just kind of play. So other than I know what the x's should be. So y equals, clear this junk out. First function, x squared plus 3x. I know my x's have to go between 1 and 6. My y's right now are going between negative 10 and 30. I don't know that those are good or bad, but they actually probably need to go higher for this. So let me go a little bit higher on the y's. Maybe make it go to 50. Kind of want to see the whole graph. Looks good enough. There's my x squared plus 3x. Now I'm going to graph 2x squared minus 2x plus 4. Y equals 2x squared minus 2x plus 4. These are both parabolas, so it might be tricky to figure out which one's on top, so I have to really pay attention. This one being drawn now. Whoa. It looks to me like at 0, they're tied, and then the 2x squared function is below, and then it sneaks above. So I need to find this x value of where they flip-flop. So I'm going to find it real quickly. Second calc, value intersect, enter, enter, enter. 4 is perfect. So let me try to copy this graph the best I can and put some color into it so you can see what's going on. So I'm going to graph this here like this, and from x equal to 1 to x equal to 6. Let me recalibrate that. Clear. Graph it. So this one starts off and just goes up like that. It's not the best representation, but it's good enough. Now I'm going to introduce, I deleted that other function because I didn't want to, it was messing me up. And this function, when I graph it, I'm going to graph it in orange. They start off tied, and then it goes like that, and this is at x equal to 4, they flip-flop. So what happens between 1 and 4, I need to do the f on top. Between 4 and 6, I need to do the g on top. Ugh. Really not excited to do this, but I'm going to do it. So I need two integrals. I need one integral from 1 to 4. The pink function is the top function, which is the x squared plus 3x. And then I need to go from 4 to 6. And from 4 to 6, I need the orange function on top. For both of these functions, I should clean this up. So for this function, cleaning this up, you have an x squared plus 3x minus 2x squared plus 2x minus 4. So cleaning that function up, you get the integral from 1 to 4. X squared minus 2x squared is minus 1x squared. 3x plus 2x is plus 5x. And the minus 4 just hangs out. So that's the first function that I'm going to integrate. And let me clean this one up as well now. This is going to be 2x squared minus 2x plus 4 minus x squared minus 3x. 2x squared minus 1x squared is 1x squared. Minus 2x minus 3x is minus 5x. And the plus 4 is just a plus 4. So one function I'm going to integrate is that. The second function I'm going to integrate is the integral from 4 to 6 of x squared minus 5x plus 4 dx. So these are the two functions I'm going to integrate. One represents, the top one represents that area, the bottom one represents that area. I'm going to do them each on a separate sheet of paper and then add the two results together. So the first one I'm going to handle is the integral from 1 to 4 of negative 1x squared plus 5x minus 4 dx. This, when I integrate it, I get negative 1x cubed over 3. This one I get 5x squared over 2. Last one I get minus 4x. Have to evaluate from 1 to 4. So I'm going to go negative 1 times 4 cubed over 3 plus 5 times 4 squared over 2 minus 4 times 4. Put my minus sign, parentheses, negative 1 times 1 cubed over 3 plus 5 times 1 squared over 2 minus 4 times 1. Calculator time. Main screen calculator, so second quit. So negative 1 times 4 cubed divided by 3 plus 5 times 4 squared divided by 2 minus 4 times 4. Math, enter, enter. That's 8 over 3. Bring my minus sign down, work on the next parentheses. Negative 1 times 1 up arrow 3 divided by 3 plus 5 times 1 squared over 2 minus 4 times 1. Math, enter, enter. So it's minus a negative 11 over 6. So I'm going to make that a plus. I'm going to do 8/3 plus 11 over 6. I get 4.5. And as a decimal, it's 4.5. I'm going to get 9/2. For my answer to this, I'm going to double check this on my calculator by going y equals clear, clear, negative 1x squared plus 5x minus 4, graph it and integrate from 1 to 4. So second calc 7, lower limit 1, upper limit 4, better see 4.5. Otherwise I made a mistake. Beautiful. So first area, this area right here is 4.5. We'll move on and find the second area by doing that integral on a separate sheet of paper. So next integral that needs to be completed is the integral from 4 to 6 of x squared minus 5x plus 4 dx. This integrates to x cubed over 3. That integrates to 5x squared over 2. That integrates to 4x. I need to evaluate from 4 to 6. So the first one I'm going to do 6 cubed over 3 minus 5 times 6 squared over 2 plus 4 times 6 minus 4 cubed over 3 minus 5 times 4 squared over 2 plus 4 times 4. Calculator time. You could definitely do this without a calculator if you really have the desire, but I don't really care. I don't want to do those. So first parentheses, 6 up arrow 3 divided by 3 plus 5 parentheses 6 squared should be minus 5 parentheses 6 squared over 2 plus 4 times 6. Oh, 6 is such a nice number. Second parentheses, 4 up arrow 3 divided by 3 minus 5 times 4 squared over 2 plus 4 parentheses 4. Math, enter, enter. So I get negative 8/3. So now I need to do 6 minus the negative 8/3. The double negative turns positive. And I get 8.66 repeating. Math, enter, enter, which is 26 over 3. I'm going to see if I get that when I do that integration. So y equals clear x squared minus 5x plus 4, graph it, second calc 7, lower limit 4, upper limit 6, better see that number, which I do. So this is the second area that I needed to find. That's this region right here, has an area of 26 over 3. I need to add this area and this area. Of course, I wanted fractions for 4.5, and 4.5 as a fraction was 9 halves. So the area is going to be 9 halves, the area of one region, plus 26 over 3, the area of the second region. And my answer is going to be whatever those add up to be. And I'm going to just do that on my calculator because I don't care to do that fraction adding that's so easy to do with my calculator. A bit of a nuisance to do by hand. And my answer, the shaded regions, when you add the two areas together, 79 over 6 units squared. Alright, so I'm going to pause this part of the video here. So finish 21 up, and then we'll move into the last part of the last section of the semester. And it's not terribly new, but it's just a little bit.